here. So last time I started to teach interrupts. So here, in the first section here, I almost finished this section. In this section, I explained the concept, the idea, and I made it very clear that interrupts are very, 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 very important. There is no way you are gonna make a real application without interrupts. You are gonna use it for sure. That's why it's very important. You should understand the topic. So here, I spent a lot of time so that you can understand what is the idea, what is the concept, and so on. So what I said last time, that interrupt means there is an event, okay? And it's gonna be more clear later what to mean by event. And because of this event, the CPU is gonna suspend the execution of the program to execute a subroutine, and then it's gonna come back here. So as you see here in this figure, that's what I explained last time. This is your program is here. If there is an that's what I told you actually in chapter 2. After this instruction, the CPU is going to execute this instruction. This is not very accurate. Okay. So to be more accurate is after executing one instruction, if there is no interrupt from any source, the CPU is going to execute next one. However, if there is an interrupt, so the CPU is going to execute a subroutine related to this interrupt. And as you are going to understand better later, we have different sources of interrupts. Okay, so for example, I may get interrupted from analog to digital converter. I may get interrupted from timer. I'm going to get interrupted from external requests. Okay, so or maybe from serial communication unit. So you have a serial communication module or unit. This unit is going to interrupt the CPU, okay? So anyway, so what you should understand now, we have different sources of interrupts. Again, it's going to be clear later. Any source, any one of these sources can request or can interrupt the microcontroller. And every one of them should have a subroutine, its own subroutine, okay? Or for every source, there is a subroutine, and you have to write here a code related to the subroutine. So, for example, if the serial communication unit is telling me I received data, okay? So, what should I write here in the subroutine? What should I have to write? I have to read the data. I have to store it somewhere. Makes sense, right? Whatever it is. So anyway, so you have to do something here. So every time if there is an event, so an interrupt subroutine is executed. And again, this is a tricky part. It looks like you are calling a subroutine, because that's exactly what I did when we wrote an instruction here to call a subroutine. That's true, but it's not. It is true in the sense that you are going to leave the main program, execute a subroutine, and come back. It's true. However, you have to be careful. In case of a subroutine, I am the user. I'm the one who's going to write instruction to call it. But here, I'm not going to call it. You got what I'm saying? There's an external event that's going to come at any time. I may not have much control on it. So once there, for example, and that's what we're going to do in the coming lab anyway. So for example, every time you press the push button, you are going to trigger external interrupt. I don't know when the user is going to press. It can happen at any time. You got what I'm saying? So this is a very serious part. I'm not going to write an instruction to call the subroutine, but the event when it comes, I don't know. If there is a fire, for example, I have a fire alarm. If there is a fire, the fire alarm is going to trigger, it's going to request the interrupt. You got what I'm saying? So when it requests the interrupt, it's going to call the subroutine. So I have to make it very clear. Okay. More importantly, I also last time I explained why interrupts are you told us this is a very important topic. You are going to use it no way to make real application without it. Why you are saying that? Simply because, as I explained last time, you can actually better utilization of the CPU. I give you one example here. You can expand this example to many other examples. For example, if I want to delay in chapter 2, when I did the delay, who did the work? Who counted for 1 second? In chapter 3, who did the work? The CPU did the work. The CPU had to run several for loops to count for 1 second. Is that okay? So by this is a bad idea, because the CPU is going to be too busy. If I ask someone else to help me, please come and help me, okay? Count for 1 second, and when you are done, please let me know. That's exactly what happens. So now I'm free. And this guy, for example, is counting for 1 second, and when he's done, he's going to notify me. So now I'm free, okay? So what it means you are free? It means I can run something else. And this is the main point. You got what I'm saying? So that's what I said. We can have an hardware circuit, external circuit, we call it a timer. And instead of doing the work by myself as a CPU, no, someone else will do it, okay? And then every time you can trigger me every 1 second. You got what I'm saying? So that's how this is just one example for timer. You can also have the same example, for example, for serial communication. So I don't need to do any work. The circuit, there is an external circuit. The circuit will do the work. And when it is ready, with the serial communication circuit receives some data, it's going to notify me just to go and take it. You understand what I'm saying? So that's how we can make big programs. Also, I give you, this is one example to understand why with interrupts we can make big application, real applications, okay? Also, here I also explain, I give you example here. From this example, you should understand the concept. This is very important. What we have done so far, I just use the main program. I can use the main program to run only one test, okay? Actually, in any real application, I should have, that's what I'm going to say right now is extremely important. Try to understand it, okay? What I'm saying is that for any application, any real application, we should have several tasks. I need the CPU to take care of, for example, of the sending signal, take care of the keypad, take care if there is a communication, receive a message from somewhere. Also, should take care if there is a fire alarm or there is something coming from the sensor. So I need the CPU to do several things at the same time, multitasking. How can we do it in multitasking? So that's what you should understand. Now, we have your program is not going to be written after I teach interrupts. You should understand that, okay? You may not understand it now, but just keep it in mind. Once I finish the topic, you should understand it. Now, my program is not going to be written in one place anymore. Okay, what do you mean? I mean, in the main, I can put one task. And for one interrupt, like for example, external interrupt, I can put another task. And then another task here, another task here, another task in the timer, another task in analog to digital, another task in the serial communication, okay? This is exactly multitasking, that's true. That means the CPU can run multiple tasks at the same time, Okay, but how it works? Let's agree on something. The CPU can only execute one instruction at a time. So here, how I can run multiple tasks at the same time? How I can do it, given that the CPU can only execute one instruction at a time, okay? I told you the idea is that what happens is that this is the main program. Once there is an interrupt, it's gonna go execute it, come back. Go execute it and come back. Interrupt from here, go execute it and come back. Go execute it and come back. Go execute it and come back, and so on. And remember, every interrupt here has a hardware that's gonna do some of the work, right? So if you have enough speed, that's what you should understand. If you can do something like that quick enough, so you're not gonna feel that this program is suspended. You are gonna feel like everything is running at the same time, which is not true. You understand what I'm saying? But if I do it quickly enough, if you do it slowly, you are gonna start you will see. So for example, if you are running a buzzer here, or you are using LCD and the keypad here, and if the system is not fast enough, you will start to feel that it's slow. When I press a keypad, it's gonna take some time until I see it on the LCD. Why? Because the program is suspended. You get what I'm saying? That's why always it's a very good advice that the code you have to write in any interrupt subroutine should be minimized. You have to try to spend as minimum time as possible here. This is a golden advice, a golden rule for any subroutine. Try to not spend too much time here, because you have to understand, if I spend too much time here, this task is not gonna, you are not gonna take care of the other tasks. So usually you have to, if for sure, if it is possible, don't write too much code here if you can, so that you can do it quickly and come back, okay? Anyway, so here also I try give you example to understand exactly what I'm talking about. I told you I wanted to do two things. I wanna do the keypad and LCD, and that's what we are doing today. Also, on top of this task, I wanna do another task. I wanna turn the LED on and do it off. Okay, for sure you cannot do it without interrupts. Okay, because in the main program, when we did the flashing LED, the CPU was busy all the time, right? We don't have time to do the keypad. Okay. Anyway, with interrupts, I can do it simply because what happens, I can put today's lab, which is the keypad and LCD, I can put it in the main program. Also, the flashing, I can put it in one subroutine. This subroutine is related to the timer, and the timer is gonna interrupt every. I'm gonna configure. This is configuration. I'm gonna teach it for sure. I can configure the timer, or I can ask the timer to interrupt me every 1 second. So what's gonna happen is that every 1 second is gonna come here, execute this one, come back. Every 1 second, come here and go execute this back. By this way, I can do 2 tasks at the same time. You can expand this example to do 3 tasks, 4 tasks, and so on. Okay, guys. Also here, I explained the difference between what pooling means, pooling and interrupts, and why interrupts is much better than pooling. But you should understand what I mean by pooling. So as I told you in this example, if you have an external ping this way, and we have connected to a sensor, okay, and then every time the train comes, every time the sensor detects a train, so it has to generate a pulse this way, okay. So pooling means continuous checking. So here the CPU has to check the pin. Are you one? No. Are you one? No. So that's what I mean by pooling. So continuous. You have to continuously check the pin. For sure, again, that's not a good idea, because the CPU is going to be busy all the time just checking the pin, right? And if you don't do that, you may miss. So for example, if someone can tell me, no, I will check it every 10 milliseconds. Okay, you can do that. But in this case, if you want to do something like that, you may miss this one. So it has to be continuously. So you have to continuously check it. So the other idea, which is much better, no, I'm not gonna continuously check the pin. I'm gonna connect this pin to what we call external interrupts, so that, and this is here in this chapter, I'm gonna teach you two interrupts, as I told you. One is called external interrupts, the other one is called for timer. So external interrupt is here. Every time there is rising or falling, you can decide or you can configure it. Okay, so every time this happens, subroutine is executed. Interrupt, you make interrupt and a subroutine is executed. You got what I'm saying? So here CPU does not CPU. I'm gonna ask external circuit. The external circuit is gonna check if there is hardware. Okay, it's gonna check if there is a falling edge or not. If there is no falling edge, so the CPU is free, can do whatever, you can do something else. Okay, so I don't need to check. Once there is a falling edge, so the external circuit is gonna trigger me. It's gonna ask me, so I'm not gonna do the monitoring by myself, so that I can take care of other things. This is, you should understand. Anyway, the concept is very important. I spent a lot of time to explain it. Okay, so here I give you some kind of a funny example here. If, for example, if the siren is not working in my phone, so and someone can call me at any time, you got what I'm saying? So what should I do? Every time I have to look at no one is calling me. So continuously I have to check, right? So this is exactly the same idea of if you don't have interrupts. Every time you have to check. Every time you have to check. You got what I'm saying? But with interrupts, no, I can do and go do something else. And when someone calls me, actually it will ring. And at this time you can interrupt me. You understand what I'm saying? Anyway, so again, you should understand the concept between polling and interrupts. You should understand why interrupts are very important before we move forward, okay? So here I write something here, hardware triggered software action, very important. So the trigger comes from the hardware, the action is gonna be done by the software by executing the subroutine, okay? You can respond to external events efficiently. So what I mean by efficiently here, I'm not going to take much time from the CPU, okay? While avoiding busy way. When no events, the processor can do something else, okay? I'm free if there are no events. Interrupts enable microcontroller to respond to human input. What you mean by human? That's what we're going to do in the coming lab. Human input means so in the coming lab, we are going to connect the external here. This one, we are going to connect to push button. So that every time that's what I mean by human input. So every time I push the push button, you are going to trigger interrupt, okay? Interrupts allows the processor to do multiple things simultaneously. This is also what I explained, very important thing. Okay. Yeah, that's also what I explain. So as you see here, every time, this is the main program. Every time there is an interrupt, I'm gonna go execute a subroutine and then come back, okay? Any questions? So here I spent, I think, a lot of time just to make sure you understand what is the idea, because this is, again, this is a very important topic, okay? So that is why we are gonna do a lab about this one. Also, I'm gonna put it in the test as well, just to help you to understand it as well. Okay. Any questions? For sure, I'm gonna give you more details. Okay. Okay. Now, in the second part here, guys, I'm gonna talk in general. I'm gonna talk about, okay, we understand the idea. The idea is that you are going to leave the main program, we are going to go execute a subroutine and come back. But there are a lot of, but how this can be done in details? How? So for example, this subroutine, where I can store it, okay? And also, when you leave the program, you may change the register, and this can make a trouble to the program, okay? So there are a lot of questions we need to answer, okay? So that's what I'm going to talk here in general. So this one is going to be in general. For any interrupt source, there are some things you have to do. So there are some things the hardware will do for you, and there are other things you as a programmer you have to do. You understand? That's what I'm going to explain here. So there are some things the hardware will do it, and other things you need as a programmer to do it. And then after that, when I come to this specific source, I'm going to explain how these software things are going to be done in this source. Here also, I'm going to talk about how this software stuff are going to be done by this specific source. So here I'm going to talk in general. For any interrupt, you have to do 1, 2, 3, 4. When I come here, I'm going to specifically, I'm going to talk about this one. But I'm gonna show you how 1, 2, 3, 4, how I can do it for this source, how I can do it for this source, and so on. So let's start with this is the big picture here about what usually happens when interrupt is triggered. So as you see here, guys, because okay, so let me tell you before I proceed. There are several in order to implement the interrupt. There are several things. There are several questions we need to answer in order to implement the idea of interrupts. There are several things we need to answer. Number one, the first thing I'm gonna answer right now. Number one, you told me when there is an event, I have to execute a subroutine. Is that okay? That's how it is. This is interrupt. The first question: where is the subroutine? Where is the subroutine? You told me there is a subroutine, but you didn't tell me where is the subroutine. Where is the location of the subroutine in memory? Is that in location 7,000, 8,000, 2,000, 3,000? Where is exactly? This is something we need to answer. How I can tell the hardware, for this interrupt source, you should find its subroutine in this location. For this source, you should find it in this location. So this is the first question I'm going to answer right now. There is another question I need to answer. Number two. Second question is, we need another issue. Priority. Okay, let me write it right. Priority. So what this means? It means if there are two sources are requesting interrupts, which one is more important? Which one I have to do first? There's also another question. Does it matter or does it matter? For sure, sometimes it doesn't matter. It depends on what is the task everyone is doing. Okay? So for example, I have interrupt that takes care of fire. This is a very, very serious issue, right? So this not is going to be something similar to an interrupt is coming to me for example, for multiplexing of the 7 segment, just to run the 7 segment. Okay? No, this is not an important one. So sometimes some interrupts are more important than others. So I have to give more priorities than this one. I have to kill the hardware. If you have these 2 interrupts, okay, please do this one first before this one. Is that right? That's also the second topic I have to address. Number 3, I should have some capability to enable or disable interrupts. For some reason, I don't want any interrupts from anybody. So I'm going to tell you, please don't ask any question until I finish this part. So I'm going to disable any interrupts from all the sources. Okay. So there should be, as a programmer, I should have some capability to enable or disable interrupts. So this is another thing we have to do. So what do you mean by enable or disable interrupts? What it means? Okay, it means, okay, what is interrupt? Interrupt again means event, and for every event I have to execute a subroutine. This is interrupt. Is that okay? So and I told you, execute the subroutine, we use the term you serve the interrupt. So when I execute a subroutine, we use the term serve the interrupt. So if the interrupt is disabled, okay, you can request interrupt, but I'm going to ignore you. What this means, ignore me? It means I'm not going to execute your subroutine. So if you disable the interrupt, that means if you request interrupt, I'm not going to execute your subroutine because the source is disabled. Okay, so that means, in order, if there is an event, now I'm giving you more details. If there is an event, in the beginning, I made it easy. I told you every time there is an event, execute a subroutine. This is not very accurate. To make it very accurate, if there is an event, there are 2 conditions. There are 2 conditions in order to go execute subroutine. The first condition, is this interrupt enabled or disabled? Disabled, I'm not going to go. I'm going to ignore you. That's number 1. Number 2, priority. Are you if this interrupt is the only interrupt I have, okay, so I'm going to go execute it. But if I have multiple interrupts, now I'm going to look at the priority. I'm going to see which one has more priority. You got what I'm saying? This is exactly how it is. So every time there is an event, it doesn't mean I will go execute the subroutine automatically. That's not true, right? So I have to look at two things. Is that enabled or disabled? What priority it has? Is that okay? So this is also one question I'm going to answer right now. How can we do that? Okay. The other question, number 4. Okay. I told you, if you wanna, I'm teaching right now. Is that okay? Okay. If you wanna interrupt me, what would you do? Interrupt me. No, raise your hand. Yeah. So when you raise your hand, you're gonna attract my attention. Okay. So we're gonna do the same thing now. So if there is a peripheral, if there is a device wanna interrupt the CPU, the device has to raise its hand. Okay. But the device doesn't have a hand. Okay. Yes, the device doesn't have a hand, but the device has 1 bit. We're gonna talk about it. So if I wanna interrupt the CPU, instead of my hand, my bit, my flip-flop, there is a hardware bit, flip-flop. This is my hand. Every time I wanna interrupt the CPU, so the device is gonna put 1 here, and this one is gonna propagate it by the hardware to request. This is when you raise your hand to request the interrupt. Is that okay? This is also I'm gonna talk about. So this is again, we have 4 questions now. I'm gonna talk them in some details. Number 1, where is the subroutine, the interrupt subroutine, the location in memory. Number 2, priority. Number 3, enable or disable. Number 4, about this what we call flag bit. Okay, interrupt flag bit. Okay. So anyway, let's go through it. So look at the big picture here. The big picture, as you see here, guys. Number 1, this is the main program here. This is the main program. At this moment here, there is an event. So what's going to happen when there is an event, as you see here, so interrupt signal detected. Okay, how interrupt signal detected? How this is done? As I told you, there is interrupt signal detected. So actually, what's going to happen? There is 1 bit. The hardware is going to put here 1. Once you put 1 here, so the hardware is going to understand that it's similar to when you raise your hand. Okay, so it's the same thing, but the hand here is 1 bit for each interrupt source. When the source want to trigger interrupt, it's going to put 1 here in this bit. That means I want to request interrupt. Okay, this is how it is. This is the language they are speaking. Okay, hardware. Anyway, this is number 1. Number 2, once there is a signal and everything is okay regarding enable, it's enabled, priority is okay. So now I'm gonna proceed to serve the interrupt. You got what I'm saying? So when you raise your hand, now I'm gonna look at enable or disable. I'm gonna look at priority. If everything is okay, so I'm gonna serve you. Okay. So anyway, so number 2, the processor is gonna stop executing the main program. Number 3, again, I told you to do interrupted. There are some things I, as a programmer, I have to do, and there are other things the hardware will do it for me. Okay, so this is what the hardware is gonna do. So the hardware is gonna automatically. This is the hardware is gonna push. Is gonna store some registers. The hardware is gonna store them store some registers in order to preserve the running environment. So it's gonna push these registers to the stack. Okay, hardware. Okay. And then after that, I'm gonna go a special table. I'm gonna explain this special table. This special table is called interrupt vector table. This table should store the starting address of every interrupt source. You got what I'm saying? So I have to go again. I want to execute your subroutine. So I want to know where is the location of your subroutine. Okay, who's gonna tell me where is the location of the subroutine? The beginning address. Who's gonna tell me? There is a special table. I'm gonna explain right now. It's called interrupt vector table. I'm gonna go to this table. I'm gonna, for every source, there should be 4 bytes. Okay, for 1 address. So the beginning address should be stored here. So that's exactly what I did. So I'm gonna go to here to the table. From this table, I'm gonna resolve. I'm gonna get the beginning address. I'm gonna put the beginning address in BC, the beginning address of this source, because every source has a different beginning address. And then after that, I'm gonna go to the subroutine to execute it. after we finish the subroutine, the hardware is gonna pop the register CBAC automatically, and then it's gonna go to your program. All what I explained right now is just transparent from you as a programmer. You don't know how it happens, right? You're just writing your program. You got what I'm saying? So it can interrupt can happen at any time. Just writing an instruction. As I told you, after I execute this instruction, maybe I'm gonna go see the subroutine will come back. May not. I may go, may not. It depends on if there is interrupt or not. So all of what's happening here transparent from the main program. Anyway, so let me go through one by one. So I almost answered the first question. So the first question here I asked, where is the subroutine? Okay, so actually there is a special table, we call it interrupt vector table. The beginning address of the subroutine should be stored here. So the designer of the microprocessor gives you the freedom. You can put the subroutine anywhere. It's up to you. So you can put the subroutine anywhere. However, you need to store the beginning address in this table. You understand what I'm saying? So you can put the subroutine anywhere in memory, but you have to store it. So that's what here I talked about. We call it stacking and unstacking. This is done automatically. As I told you, if there is an interrupt, the hardware is gonna push some registers, it's gonna pop them back. That's what we call stacking and unstacking. Okay. So that's what I told you guys. There is something we call interrupt vector table. Okay. So this table has this table has fixed location in memory. Is that okay? So what I did, okay, let me explain it for me to understand it better. So if you see here, guys, for every interrupt source, you can see this one is incremented by four, because here in every location here in memory, in every location I store 4 bytes. I store address, the beginning address. Is that okay? For example, I give you one example. For example, if there is an interrupt coming from external one, for example, external one, okay, and I need to know where is the beginning address of external one. So I'm gonna come this location. This location is fixed. So always external one has this location. So this location is fixed. What is not fixed is you have to store the beginning address here. So you can put the subroutine. You can put it anywhere in the memory, but you have to store the beginning address here. You got what I'm saying? So for every interrupt source, there are fixed location in memory. Every time there is an interrupt from this, you can put the subroutine, interrupt subroutine anywhere in the memory. It's up to you. However, you have to store the beginning address here, so that you need to tell the hardware where is your subroutine. So here, this location is fixed. So what you can see for every interrupt source, we have a fixed location. However, the location of the subroutine itself can be anywhere. Just to put the beginning address here. Okay. So, and also these addresses are fixed. So what happens, guys, is that we start from location 000. Okay, and then for every interrupt source, we have one address with which it's one word, which takes four locations. Also, you can see here one more thing here is that you can see in 000 you have to store the stack pointer address, stack pointer. Okay. Also, in number 4, you have to store the reset. Even the reset itself is interrupt. The reset is interrupt. And I want to tell you, okay, how the microprocessor is gonna execute your program. Okay, so the way the microprocessor is gonna execute the program in the very beginning, number 1, whatever is stored here, the microprocessor is gonna put it in a stack pointer automatically. So every time you reset your processor, okay? How the processor is gonna start executing your program? How this can be done? It is done this way. The hardware is designed this way. Hardware. Every time you do reset, whatever is stored in location 000 is gonna go to stack pointer. That's number 1. Number 2, whatever you have here, it's gonna go to PC, program counter. This is done automatically. So every time you reset your processor, whatever here is going to go to stack pointer, whatever here is going to go to PC, program counter. And actually, whatever here is the reset. And the reset, it has a subroutine. Okay? So every time you reset your processor, you are going to go to a subroutine, interrupt the subroutine for reset. And inside this subroutine, you have to call main. You have to go to main. You see the steps? Okay, so again, what I'm saying is that this is how it works. Every time you turn on your processor or you reset it, two things are done automatically. Hardware, this is how it was manufactured. Whatever here in this location is going to go to stack pointer, whatever is going to go to PC. And whatever here is actually the interrupt subroutine for reset. Every time you do reset, I'm going to come to here. Among other things I can do here in this one, you are gonna call main. What I'm saying? Whatever is the location of main, so you can put main anywhere, and then this one is gonna call it anyway. So, any questions here, guys? So again, here I'm answering one question. The question is that, can you please take a seat? You make a lot of interruption. You interrupted me several times. You came late and then you go and come. So if you don't want to attend the lecture, you can leave it, okay? But you don't make this interruption. Anyway, so what I'm saying, guys, is that this table, you have to put the beginning addresses of the interrupt subroutines, okay? What I want to say is that, you are telling me I need to write a code to do that? The answer is yes and no. Yes, this has to be done. Yes, this has to be done. But luckily, because we create a new project, when you create a new project, this is done automatically for you. So if you create a project from scratch, so if I don't use the cube, the library you are using, and you want to create it from scratch, the answer is yes. You have to go in this location and do it. So this is, we do some kind of initialization in the beginning. So this is a part of the initialization. So what I want to tell you guys, this is something done automatically for you in your project. Is that okay? All what you have to do is that for every interrupt subroutine, there is a name for the function. And the name of this function is already written here, or the address of this one is already defined here. So all what you have to do is that every time you want to use interrupt, you have to use specific names. Because these names, the addresses of these names, or the addresses of, you remember when I told you, when you make a label, so a label is going to be replaced by the address. It's almost the same idea, okay? So what I want to tell you guys, number one, someone has to do the work. Someone has to put the beginning addresses here. And you don't need to do it because the project will do it. However, the way the project is dated, the project is gonna, then you have to use specific names. Why? Because these names already, the processor already put the addresses here. You got what I'm saying? So for every interrupt, you cannot use any name. You have to use a specific name so that because the project is going to link this name, or is going to put this name, is going to put the beginning address here. Anyway, so luckily you don't need to do it, but you should understand it's already done for you. But you have to use specific names, and you can find these names already defined in your project. Okay, guys? So to be more specific, so for example, this is most of the interrupts we have. So when the time comes, so all what you have to do, guys, here, as you see, for example, if I want to use, here I'm explaining, if I want to use this interrupt, okay, for example, this is the name you have to use. So you have to create a function. The function has to be this way. You have to put void, and then you have to put the name here. And these names are already defined. You understand what I'm saying? So this comes with the project. So once you put these names, already the project is going to put the addresses for this one's in the correct location. Okay, guys? Again, I'm talking in general, but when the time comes for every source, I'm going to tell you the specific name you have to use, okay? So if you are programming this one, you have to use this name. If you program this one, you have to use this name. If you program this one, you have to use this name. You understand what I'm saying, guys? And you should understand why you have to use specific names. Simply because you are telling your project this name, okay, this is going to put, this is for the handler, approach is going to put the address in the specific location. Okay, any questions? So now I answered the first question. The first question we need to answer, where is your subroutine? Where is the location of subroutine? Okay, how I can tell the hardware that my interrupt subroutine in this location? Okay, and now you should understand what you mean by if someone tell you interrupt surface or vector table. Okay, so if, the vector table, you should understand what we mean by vector table. You should understand interrupt vector. What this means. This we use this expression or this term all the time. Interrupt vector. That means it's beginning address. So this vector table, it has interrupt vectors for every source. Okay, guys, any questions? Any questions? Okay. The next question I want to, or the next question we need to answer is priority. I told you about priority. So here, priority means, okay, priority means two things now. Number one, if I find multiple interrupts or multiple sources are requesting interrupt. So this is source 1, source 2, source 3, source 4. Okay, I cannot execute all of them at the same time. I have to only select one. Is that okay? So there are 4 interrupts, pending interrupts. Which one I have to select? This is the meaning of priority. Is that okay? There is another meaning for priority. If I already started executing one interrupt, okay, and there is a more important interrupt came, should I leave this one, go execute it, and come back because this one is more important or not? This is another thing. So 2 things now. If I have multiple pending interrupts, which one I should do first? Okay. Number 2, if I already decided to serve this interrupt, and during when I am in the interrupt subroutine, before I finish, a more important guy requests this interrupt. Should I leave and go to this guy or not? Okay, that's what I'm going to explain. Okay, and also, is this something should be decided by the hardware, or I am as a programmer, I have control on something like that? The answer is, as a programmer, yes, we give you the control of deciding something like that. But why? Why you give me control? Simply because it depends on your application. In my application, I know this interrupt is more serious than this interrupt. This one should be, this is time sensitive, or this one doing something very serious. And for example, fire alarm or something very serious. So this one should not be, should not wait. You understand? So this is something you can decide in your application. Okay. So that's what I'm going to explain now. It's not difficult. So here, yeah. So the answer is that, guys, as you will see right now, the answer is that for every interrupt source, you as a programmer, you can give a number, a priority value for every source. Is that okay? And for example, I have source 1. I'm going to give it priority of 7. Source 2, priority of 3. Source 3, priority of 2. Which one has higher priority? The smaller the number, the higher the priority. This is how they made it. So this one, so if I get 2 and 3, so this one is more important, this one. I'm going to go 2 first and then 3. Is that okay? So now, as a programmer, you can write a code. You can write a code for each source to give a priority value. But you should understand, the lower the priority, the lower the value, the higher the priority. The lower the value, the higher the priority. Yes?
Is there ever a situation where maybe another function has like a higher priority, but for some reason the function that's currently running takes precedence and like has to finish out, or will it always go to that higher priority when the interrupts?
Okay. Again, this is something you can select. Okay, so let me finish, and then if I didn't answer your question, you will get it. Okay, so this is something you can select. So I'm gonna look up. So okay, guys. So for now, you should understand lower value means higher priority. Okay. So the question is that how I can do that? Very simple. For every interrupt source, we have a register. You can write this value in this register. That's it. Pretty simple. This register is called interrupt priority register. Okay. So this is actually this one is actually array of bytes. Array of bytes. This register is actually so this is IB, but this is IB of 0, IB of 1, and so on. So array of bytes, where every source has 1 byte here. every source has 1 byte. Okay, in this byte I can write the value. Very simple. So again, for every source it has 1 byte. I can write the priority value to this. Okay, how can we write the priority value? So this is how it is. Yes, it is a byte, but actually I'm not going to use the whole byte. So what's going to happen, as you see here, the first 2 bits here, we call them preemption priority. I'm going to tell you what this means. And the second 2 bits here, we call it sub-priority number. Okay? So 2 bits for preemption priority, 2 bits for sub-priority number. We don't use the other bits. Is that okay? This is the byte for each source. Okay, look at the story. What is the story? I'm going to tell you. So this preemption, what preemption means? This preemption means, okay, when I execute an interrupt, okay, guys, and came another interrupt, should I leave and go to this interrupt or not? This is the question we need to answer. You know what I'm saying? So I'm executing an interrupt. I didn't finish it yet, but there is another interrupt coming from somewhere else. Should I leave and go, or should I wait until I finish and then do this one? Which one I have to do? Who's going to tell? Who's going to tell is this one, preemption priority. For example, if this one has the preemption priority of 3, but this one has a preemption priority of 2, and 2 is higher than 3. So this preemption priority can tell if should I preempt or preempt here means leave this interrupt to go execute the other one. That's the meaning of it. Okay. So if for example, so these 2 bits can tell this case what should I do. For example, if this one this one has 2 here, number 2 here, but this source, for example, has number 3. So what's gonna happen? No, I'm not gonna come here. Why? Because 3 has less preemption priorities than 2. So I'm not gonna leave this one. I'm gonna continue executing this one because this one cannot preempt this one. You got what I'm saying? However, if this one has a smaller number, for example, this one has 2, for example, okay? Sorry, 1, for example. 1 is less than 2, okay? So that means you are saying this one can preempt this one. This one is more important. So if when I execute this function, if this one comes, you have to leave and go there. Okay. Again, this is something I spent too much time explaining about priority, but maybe for purpose of this course, we may not need it much. But again, you should understand it because in the future, maybe you are going to make big programs. You have serial communication. You want to if you get interrupted from the serial communication, you have to solve it first before you do anything else. So, but anyway, so this is the main idea here. So again, guys, so preemption priority should tell if I'm executing a function, should I leave it and go execute another one or not? Okay. So if the new one has more priority based on the preemption, the answer is yes, you are going to do it. Unless no, you are not going to do it. Okay. What about the sub priority here? I'm going to tell you what it means. Okay. If there are bending interrupts, so I have several interrupts at the same time. Okay. Number one, I'm going to look at the preemption priority. For example, if 2 of them have the same preemption priority, I need to select which one I have to select. Okay. So if two of them have the same preemption priority, in this case, I'm going to look at the sub priority number to decide which one I have to select. You guys, this is a different scenario. So there is a different scenario if I have several bending interrupts. Is that okay? Which one I have to select? Number 1, I'm going to look at the preemption. If 2 guys have the same preemption value, so in this case, I'm going to look at the sub priority number to see which one is more important to execute it first. Is that okay, guys? So again, this is something, so you should understand you can control 2 things now. You can control 2 things. Number 1, whether an interrupt can preempt. You should understand what I mean by preempt. Preempt means you are going to suspend executing an interrupt to go to serve a more important interrupt. Is the meaning of it. You can control it, right? Also, if you have multiple pending interrupts, okay, which one should be done first? Also, you can control it simply by writing some number in a register for every interrupt source. So every interrupt source has a byte like this one in this register, okay, IP register, okay. So, and actually every interrupt, if you look here, we have what we call interrupt number. So, and I got this picture from your project. So if you go to this file in your project, you will find here, guys, every interrupt we have here. This interrupt is here. We call it, this is the system interrupts. So this is from the system if there are a fault or something like that. So this is for the system. Most of the time, we're going to focus on the peripheral interrupts. Peripheral interrupts are here. And you can see here, guys, every interrupt has a number. So I'm going to tell you how can you use this number. So for example, if you use this interrupt, the number is 0. I think next time we're going to use this interrupt. So the number is 7. This interrupt is number 6 and so on. As you see here, guys, this all the interrupts we have. Every interrupt has a number. Okay, I'm going to tell you how we can use this number. Okay, so the way we are going to use this number is, guys, I told you now we have an array of IP, interrupt priority, to determine the interrupt of everyone. Okay, if I wanna, so for example, this one, where is the IP of this one? Is going to be at location number 7. Very simple, because the interrupt of this one is number 7. So, okay, if you want to program this one, where is this one? It should be at location of 20 and so on. So again, very simple. When I say IP, and then you put 20. So this one is going to give you the register, the interrupt priority register for interrupt number 20, which is this one. Got it? So now I can show you if, yeah, for example, as you see here, guys, so here, this IP is under the structure NVIC. I'm going to tell you what is NVIC later. So here, if I want to, this is the IP register, I'm going to write number 60, as you see here. Okay, guys, so very simple. So if you want to set the priority, if you want to set the priority for any source, you can do one of two things. You can do one of two things. Number one, I can say NIV, okay? Sorry, NVIC, and then you are going to see here IP, and then here you have to put the interrupt number, okay? And now you can say equal whatever. Yes, by this way, you can write a certain value to the interrupt priority. There is another way. Another way, you can just call this function. So in this function here, you have to send two things. Here, I have to send the interrupt number. You have to tell me which you want to set the priority for which interrupt using its number, and these are the number of all interrupts you have. So if you want to set the interrupt priority of this one, I have to use 7. If I want to do this one, I have to use 15, and so on. Is that okay? So, and then here, this is the value you want to write. So I want to write 6. I want to write number 6 in this priority. Okay. Any questions? So again, let me summarize what I said. Number one, I explained the idea of priority. One, you should understand what I mean by priority. You should understand. Don't understand why I give this control, why I allow the user or the programmer to control priority. Very simple. Because maybe some interrupts are doing something that are more time sensitive or something that's very serious. Should be this one has to, if two comes together and this one is doing something more important than this one, so I have to do this one, or time sensitive. Okay. Anyway, number 3, you should understand how can you do it, and how can you do it? Very trivial. All what you have to do, just write a number as I explained here. You have to write it in a register this way, or you can just call this function. Also, you should understand the number you are going to put here. The lower the number, the higher the priority. Is that okay? Anyway, the other question we need to answer, and it's going to be easy. I told you here. So I already answered the first question. Where is the interrupt subroutine? The second question I already answered. What about the priority? The next question I want to answer is about enable and disable interrupts. I told you as a programmer, I should have the capability to enable or disable interrupts. Is that okay? What is the meaning of it? I already explained. The meaning is that I told you if there is event, event coming from interrupt, I'm going to serve the interrupt. What do you mean by serve the interrupt? Execute a subroutine. Is that okay? I should. This is if I enable the interrupts. So if I enable the interrupts, that means every time there is an event, the event is going to trigger, is going to request interrupt. You request interrupt. And after you request interrupt, I'm going to serve the interrupt. And serve the interrupt, that means I'm going to execute a subroutine. Event, request, serve. Is that okay? This is if it is enabled. If it is disabled, event, request, discard. I'm gonna ignore you. I'm not gonna execute a subroutine. Is that okay? Is that something as a programmer I can control? The answer is yes. Yes. How? That's what I'm gonna say right now. Very easy. How? You say just one bit. Just one bit. So every interrupt has one bit. In this bit, if I put one, for example, you enable. If you put zero, disable. That's it. So I'm gonna give you more details now quickly. I almost finished, so okay. So here, what I'm teaching now here, guys, is that what is the meaning of enabling and disabling interrupts? You should understand what it means, okay? So if you disable, even if there is an event, even if you request, I'm not going to execute your subroutine because it is disabled, okay? So for enable or disable, we actually here, I'm going to talk about what we call local interrupt masking capability, local. The word local here, that means it's for every source. For every source. I can enable or disable the interrupt for every source. Also, we have something else, we call it global. Global means I can disable interrupts for all sources. Sometimes we need to do something like that. Or for a group of sources. So here, that's what I'm going to explain right now. How can you enable or disable interrupt for individual sources one by one? Or you can do it like in a group. Okay, I can disable everybody, okay, or I can disable a group, okay. Sometimes you need to do something like that. I'm gonna so now, how can you enable or disable interrupts? Very simple. Look here, very simple. The details are coming later, okay. But here as I told you, here I'm explaining in general, okay. So for every interrupt I'm gonna teach, okay, there are 2 bits. One bit here in the peripheral itself, and one bit here in a controller. It's called nested vector interrupt controller. So this controller is a hardware. This hardware should manage, or this hardware is responsible for managing interrupts. So actually, every peripheral, every device has 2 bits. 1 bit here and 1 bit here, and you have to make sure you enable the 2 bits. How? Just write one here and just write one here. That's it. If one of them disabled, the device is disabled. Very simple. So where is this bit? Where is this bit? For sure, I'm not going to tell you now. For every source, it is in different location, different register. So I'm going to tell you later. So when I come to every source, for every source, I'm going to tell you where is this bit here and where is this bit. But the idea is that for every source, there are 2 bits. 1 bit at the peripheral level. This one should enable or disable requesting interrupt, and this one, another one at the NVIC. 1 bit and 1 bit. And you have to make sure, in order to enable this source, this specific source, you have to enable this bit and this bit. Is that okay? For sure, I'm going to give you, this is in general. For every source, I'm going to tell you where is this bit and where is this bit. Okay? Any questions? Okay. But for the system, because if I go back here, I told you, we have system interrupts. This interrupt is for the system, and this is for peripheral or for the devices. Okay, for the system here, we don't have 1 bit in the NVIC. We have only 1 bit at the device itself. So here I told you, in case when I talk about peripheral interrupts, there are 2 bits. But when I talk about interrupts coming from the microprocessor or from the system or the microprocessor itself, so actually it has only this one. It does not have a bit here. It has 1 bit in the device itself. Is that okay? So again, what I'm saying, in case of peripheral, there are two bits. 1 bit here and 1 bit here. But in case of a system interrupt, there's only 1 enable bit. It's the same idea, just 1 bit. If you write 1, you enable. You write 0, you disable. Okay. Any questions? Okay. So Just 2 more minutes. I'm done. Just 2 more minutes. Okay. Now, you told us. Look here, guys. You told us there is 1 bit here and 1 bit here. Where is this bit? I'm not going to explain now. This bit is different from one source to another. For every source, I'm going to tell you this bit in this register. For this source, it is in this register. So this one is going to be different from one source to another. Is that okay? Okay. What about this one? For this one? No, for this one, it has only one register that has this one register for every source has 1 bit. Is that okay? And this is for enable. And they created another register for disable. And also every source has 1 bit in this register. Again, so here, again, I'm talking about the bit here. For this one, I'm going to talk about it later. For the bit here, there are 2 registers, okay? Every source has 1 bit here, and every source has 1 bit here. You have, if you want one for enable, so one for disable. That means if I want to enable a source, so I have to put 1 here, okay? If I want to disable, do I need to put 0 here? No, 0 is not going to make any difference, okay? So if I want to, this is how it works. If I want to enable the source, in the bit, every source has 1 bit. In this bit, I have to write 1 here. If I want to disable the source from this one, okay, so actually you are gonna put 1 here in this register. This register, once you write 1, is gonna put 0 here. It's not your, again, sometimes this is the way they made it. Sometimes, by the way, let me put it this way. Sometimes they give you only 1 bit. If you put 1, you enable. You put 0, you disable. And that's exactly what we are gonna do here. Is that okay? However, when they made this one, they made 2 bits. 1 to enable, you have to write 1 here. 1 for disable, you have to write 1 here. Someone can ask me, if I want to disable a source, do I need to disable the 2 bits? This one and this one? The answer is no. And that's what I'm going to do later. So for example, as I told you guys, every source has 1 bit here and one source have 1 bit here. The 2 bits should be enabled in order to enable interrupts, both of them. So actually, as I'm going to do later, I'm going to work on one of them. So I'm going to work on this one. That's it. It should be enough. You got what I'm saying? But anyway, so here, yeah, these are the 2 registers I told you about, guys. ISER, ICER. So this one is used for enabling, and this one is used for disable. Every source has 1 bit here, and every bit has one bit here. If I want to enable, you have to write 1. If you want to disable, you have to write 1 here in 2 different bits. Okay. So if you want to disable or okay, so you told us every source, we have a register here. Every source has 1 bit. Is that true? Yes, it is true. So for every source, where is the location of this bit? Where is the location? The location of this bit is similar to the interrupt number. So for example, if I come back here, for example, for this one here, it should be bit number 13. For this one here, it should be bit number 5, and so on. Very easy, right? So all what you have to do, guys, here, if I'm interested in the interrupt source of interrupt number 5, so I have to write it here, okay? And that's exactly what I did here. So if you see here, guys, every time you want to enable, you have to say NVIC ISER. This is a register. You have to write 1, and here you have to write the interrupt number here, okay? So when you write here the interrupt number, so actually you are gonna put here 1 in the location here. So actually you are gonna set this bit with this in this location, okay? So if you want to enable, you can use this one. If you want to disable, you can use this one, okay? Or you can use function. So this is okay and this is okay. So again, so this either the function or the register, this one can enable or disable the bit here, the bit at NVIC. There is another bit here I'm going to explain. Okay, guys? Again, if you don't fully understand what I'm saying, it's okay. You know why? Because when I teach every interrupt source, I'm going to repeat what I'm saying. Here, I'm speaking in general, what I'm saying. For every source, we need to do enable here and enable here. So when I explain how can you do external, I'm gonna do both of them. So I'm gonna repeat it somehow. Okay. So again, any questions so far? I almost finished. Okay. The last thing I have here is you told us there is some kind of global. So what I explain right now is individual. I can enable or disable one source. one by one. Sometimes I need to disable all sources or a number of sources. How can you do that? Very simple. So we have this register, priority mask register. If you just call this function and you send 0, you are going to disable all interrupts. If you put 1, you are going to enable all interrupts. Listen, this is very tricky. Listen to me. If you enable this one, that doesn't mean all the interrupts are enabled. Still, you need to look at the individual one. This is like a master switch. Okay, very important thing. So, like for example, guys, you have here a master switch. Okay, if you connect it, and also we have here a local switch. That's exactly how it is. So if you connect the master switch, that doesn't mean you connect the circuit, but still you need to do the individual one. However, if you open the global one, all of them are off. You got what I'm saying? So what I'm saying here, guys, this one like a global switch. If you disable here, all of them are disabled. However, if you enable here, a source is enabled if its local is enabled. It's not if I enable here, that it doesn't mean all of them are enabled. No, all the source that is enabled locally is enabled. If it's not enabled locally, so this is like a master switch. Anyway, so this is one way to do it. There is another capability, as you see here, guys. I can say, so this is like all of them. I can disable all of them. Also, you can say, I want to disable the interrupt that has certain priority. So this is for a group, okay? So anyone that has this priority or lower should be disabled, okay? For example, here, as you see here, so there is another way I can do it, guys, here, as you see, when you disable using this function and using this register. So here I can say, for example, if I put here, if I call this function and put 60, what this means? It means any interrupt with a priority value same or higher this one is disabled. You got what I'm saying? So again, this one is global, so I can disable everybody. This one, I can only select any based on the priority. If someone has a higher number than this one, it's disabled. Okay, guys? Again, the last thing I want to say here, guys, is that why I need something like that. Why sometimes I need to do something in the code and I don't want to any interruption from anywhere. Okay, especially if I do some kind of initialization. So in the beginning, I'm doing initialization. The system is not ready. We may not need to do it. We may not need to do it. But sometimes, as you see here, guys, for example, I'm gonna disable interrupts. I'm gonna do something critical, and then I'm gonna enable interrupts again. Sometimes I wanna run some code, and I wanna prevent any interruption for something. The last slide here, and then I'm gonna leave this one for next time. But last slide here. The last slide here, guys, as I told you, if you wanna interrupt me, what would you do? You have to raise your hand. Okay, it's exactly the same thing. Every interrupt source has 1 bit. If the interrupt source wanna interrupt, so the interrupt source has to write 1 here. This is exactly similar to you raising your hand, because once the interrupt source is gonna put 1 here in this flip-flop, okay, this one is gonna trigger, it's gonna propagate in the hardware, so that it's gonna trigger interrupt. You got what I'm saying? That's okay. So that means for every interrupt source, there is 1 bit. We call it flag bit, or sometimes we call it interrupt binding bit or flag bit. Okay. So anyway, so for every interrupt source, guys, it has 1 bit. The hardware is gonna write 1 if the hardware is gonna request the interrupt. Is that okay? So every time there is 1 here, what it means? It means there is a request, interrupt request. Okay. However, and this is the serious part, and this is the last thing, I'm not going to teach you more, that's more than enough. However, the hardware is going to put 1 here. However, it's your responsibility. It's your responsibility as a programmer. Once we serve the interrupt and we go to the interrupt subroutine, you have to write here an instruction to clear this one, make it 0. Let me say it again. So there is a very important bit. This bit is called interrupt flag bit or binding bit. Who's gonna set this bit? The device when it requests interrupt, right? Once we serve the interrupt and we go to the subroutine, it's your responsibility to write the code to clear it. You got what I'm saying? So when you clear it, what it means when you clear it? That means there is no pending interrupt. That means I already served you. You got what I'm saying? So after that, if you want to make another interrupt, okay. So this is how it is always, all the time. This is how the story is. We have fun bit. The device is gonna put one to request, and then here the iris, the interrupt subroutine is gonna clear it because it's already I served it. You got what I'm saying? So every time the device wanna trigger interrupt, it's gonna put one. Every time I clear it, okay. Well, the serious part here, very serious, very, very serious. The serious part here is, what if I forget this one? What if I forget to clear it? What's gonna happen? So this one is gonna continue be one all the time. Your program is not gonna work. Why? Because the CPU will think always this is continuous interrupt. You got what I'm saying? So what's gonna happen every time I go to the main program, there's interrupt. I'm gonna execute it and come back. And then the hardware will think there is another interrupt. Go execute, go and execute it back. So your program is not gonna work. All the time we're gonna execute this subroutine because the hardware will think there is a continuous interrupt from this software because you didn't clear it. Got what I'm saying? So again, as I'm gonna teach later, you have to write an instruction here to clear this bit. If you forget to clear it, so your program is not gonna work. You're gonna have continuous interrupts. Because when you clear it means I already served you. Okay. Again, the hardware is gonna put one here to request interrupt. The software has to put 0 here just to indicate that I already served the interrupt. Anyway, that's more than enough for today. Okay, that's enough. Okay, guys. Enjoy the rest of the lab.